Now we've got our data inside SPSS, it's time to start analysing it and get some more deeper understandings. And we're going to do this through a process of descriptives. So this is describing the data. We're not doing comparing, contrasting. We're just getting in grips with what our data is all about. It's a really important test. So the kind of things we're looking at are pulling out means, pulling out median, pulling out mode, what's the number of this group, what's the number of that group, what's the standard deviation within the groups, or is it the data even normal? So what kind of statistics should we be doing later on? So let's start by going through some simple questions that gives you some examples of what we're doing. So we could say in our data, what's the percentage of males and females? And then how many people, when they go shopping, spend between 100 and 500 renminbi on kids' clothing? We can also say why are they shopping for kids' clothing? But let's take the first two about what's the percentage of male and females and how many people are spending 100 to 500 renminbi. So let's go to Analyze, go to Statistics and Frequencies. We're choosing frequencies because our data is categorical. So I've got some data lined up here before, which we will return to later on. We're going to go to for own child and others. Sorry, I'm jumping ahead of myself. Go to gender because we want to know about men and women, and average amount spent because we want to know about amount spent. At this point, we could just press OK and go for it, but I'm going to show you a few more things to show you more about the software. So we've got the statistic here, and we can choose quite a few things here. So if we want to know the median, the mode, the mean, then we can just choose these. We can choose standard deviation. We can evaluate the skewness and kurtoise. But for this case, we don't actually need any of this. But if you do need it, it's just there. So bear in mind, this is one way to get that data from your cells. Click continue, and actually, I'm going to go for. No, this can be fine. There's one thing I want to show you again, which is charts. So at the moment I've got histograms selected, but I actually want to do a pie chart. So my data as frequencies are going to come out saying this percentage of people do this. So let's click continue and click OK. And we should get some answers to our questions straight away. So we've got first one is what percentage are men and women? So from the frequency table, we've got two percentages. One's a percent and one's a valid percent. So we might say that certain outliers are there, certain ranges are invalid. We're going to remove them from our data. But in our case, we haven't removed anything. We're going for the full amount, which is 12.8% are male, which is 39 people, and 87.2% are female, so that's 265 of the 304 sample. If we go down to the bottom here, we see a pie chart which visualizes it, makes it really clear and easy to do. So I do like these, make it easy to see. Next question is, how many people spend between 100 and 500 renminbi on their shopping? Simple, look at this average amount per purchase, and we'll see that the answer is 169 people, or 55.6%. Looking at our second pie chart here, we can see that it's the green area, so that represents a very large proportion of people, with the second amount spent between 500 and 1,000 renminbi. So overall, the people we've asked spend between 100 and 500. So that's a pretty easy way of doing this. So what's the next question, which was, what's the purpose of buying? Why are people shopping? And what's the underlying groups in the shopping? So very easy again, go to Analyze, Descriptives, but this time choose Crosstabs. This is a very simple matrix. Now I've already loaded this up, but I'm just going to unload and do it again. So question 5 asks, why do you go shopping? So if you shop for your own child, well, you ticked one box. If you shop for someone else's child, you clicked others. So we have those two areas. Now in cross-tabulation, there's different statistics we can pull up and we can do, but we don't need that for this. We're doing a very simple question, but just being aware this menu does have lots of options for lots of tests. But I'm quite happy with this. I'm just going to go ahead and click OK. And we're going to get an answer coming up now. And it's this item down the bottom here. So we can see that no one is going to buy clothes not for themselves and not for others. That's not surprising actually, because who else would you buy it for? It's not for you or for someone else. So we can say that 117 people, so most people, are buying it for their own child and not for others. We see that 80 people are buying it only for others, and 107 people are buying it for themselves and others. Now this tells us that the amount of people who are shopping these three categories are pretty equal. Obviously there's a lot more people buying it for their own child than for different child, but it's not such a massive amount that we can't do stats with it. So we could consider taking these questions further and doing further analysis. Now, I could go into all the different sections in this in this SPSS file and doing a lot more analysis and getting to grips with all the different things like what's your frequency of shopping for this and what's your age, where do you live, but we don't need to. But if I was to do that, I'd use the same techniques. So let's move on to the next question, which is saying, is our data normally distributed? Now this is a really important question because normal distribution tells us, are we going to do parametric stats, which is yes, you have normal data, or we have non-normally distributed data, which means we should be using non-parametric stats. So how do we do this? There's a few ways of doing it, but I'm going to show you my favorite method, which is the most powerful method. So go to Analyze, Descriptives, but we're going to go for Explore rather than Frequencies. So when we're in here, we've already got this loaded up, but I'm just going to unload it to go through it again. We choose all our scale items, which is, in our case, PV1 going all the way to R12. Move them into the dependent list, and then select the participant ID and move that into the label cases by. So we just know that each person is an individual case. In the display section, we choose both, so not just statistics, we're doing statistics and plots, and we're going to show them both. So now we've got to tell it what we want to do. Let's click on statistics, and we want to have descriptives, and that's going to be have 95% confidence, and we want to have outliers. So let's both select a fine. Go on plots, and we want to have histogram, and want to normalize plots themselves. You might find that when you open these up, something like stem and leaf is selected and not histogram. That's fine, just unselect it and select histogram. Click continue. And now click options. Now the options are to exclude cases pairwise. This just helps with the way that SPSS deals with data that is not there, so missing values. Click continue, and we can leave it as it is right now. We're ready to go. So click OK. Now it'll take a second to run through this because we're running 20-something independent calculations. So this is a MacBook Pro with i7 processor. It's going to take some time. So if your computer's a bit slower, it might take a minute or two, but it won't be too long a wait. What it's doing is generating all the statistical equations as well as the images. We've seen something flash up here, so let's go and have a look. There's a lot of images here, but all we really need to look at is we have our descriptives. So we've got our mean and a 5% trimmed mean. This is the first thing you look at. Now, there's something called the Bill Gates effect. So if you walk into a pub, there's people there with an average income of maybe £25,000 a year, which is the UK average income. So you get your guys with the road, you get your guys who are in business, put all their incomes together, divide by people in the bar. You've got your average income, which would be about 25 grand. So Bill Gates, a multi-billionaire, walks into the room, and the amount of money which is earned is suddenly shot right up, and everyone in the room is now seen as a millionaire, as the mean. That's not actually how it works. The reality is not everyone's a millionaire. It's that the outlier is, and the 5% at the very end, that 99% part, is really racking the data right up. So what 5% trim mean is it takes off the bottom and top 5% and looks at the mean score for that. Now we can see that our mean for the whole data and our mean for the trimmed is about the same, going from 5.26 to 5.29. So we can conclude that there's not a massive difference happening, there's not a major influence from our 5% areas, so we can carry on without worrying too much about our outliers. Second area, we can look at skewedness or kurtoise. Now, in a perfect bell curve, you're going to have values of 0, so we're not too bad. But what we can do is we can go, these values are acceptable. Let's go and have a look at our histogram. It looks okay. Now, that's a very imprecise way of doing it, so I want to find a more precise way of saying, is this data normal, yes or no? go on the left here to test for normality, and you get this table here, which is absolutely fantastic. So what we do is we look here on the Kolmogorov-Smirnov process, that one wrong. Got the test there in the first set of columns. Now, we've got PV1, PV2, PV3, etc. Our statistic, our degrees of freedom, but the part which we really care about, which really tells us what we're doing, is significance. Now, the new student might look at this and go, all of our results are significant, therefore our results are normal. Fantastic. No, that's not how it works. If you have significant outcomes, that means that your data, your scales, are not normally distributed. What you have is non-normality, a violation of the assumption of normality. So all our scores here are significant. The data is not normally distributed. That means that for analysis in this dataset, we should be looking at non-parametric alternatives to parametric statistics. So if you normally will do something like ANOVA, so analysis of variance, you should be looking at Crosstabulation, which is the alternative. So that is that. So by using descriptives, we've understood the data, we've gotten deeper, and we've decided which pool of stats we're going to be using to analyze the data further.